Hey guys, what's up everyone? Welcome or welcome back to another video from the AP3X Institute of Mathematics Education. My name is Akeen and we are continuing on a series of structured practice questions as we gear up for the 2023 exams starting in May. Now, in my two previous upload, I had constructed a few questions that I had given to my students that I currently teach. And I think that this tutorial gives us a clear indication of the type or structure of questions that you're expecting to come on the exam. More or less the same level of difficulty. All right, now we had already done question 1, which is the bearings, and we had done question 3, which is the measurement. A link will be provided in the description box below, so click on those links and check those tutorials out. Very interesting way of going about the problem. Now, in this particular tutorial, we're going to be looking at transformation geometry. Alright, and hopefully if we can get through all the finer details of how to approach a question like this, then we will be able to add on another question. But if it gets a little bit too long, we might just end the video and start another upload. Alright, so let's just see how we go about attacking this particular problem. Alright, if this is the first time here on the channel, consider smashing that subscribe button below, turning on your post notification bell to be notified whenever it is that I upload on a weekly basis 2 or 3 times. Leave a like if you're getting any value from the content, and of course leave your comments, suggestions and video requests down in the comment section below. So let's just jump right into the video. Alright, so it says here that the triangle EFG has coordinates, E being at the location -1, 3, F being at the position 2, 5, and G being at the position 6, -2. Alright, and so it undergoes a glide reflection consisting of a translation by the vector -2, 3, followed by a reflection in the line y equal -x. Our first task is to calculate the coordinates and draw the image E prime, F prime, G prime after the combined transformation. Also, you must show your pre-image. Alright, so I mean, naturally here, before we even look at the technical aspect of the problem, the first thing we naturally have to do is to get this on graph. So we need to see what our image looks like here, or what our object looks like on graph paper. Alright, and I strongly encourage that when you're plotting a graph, well, usually on exams you get a graph that is, or you get coordinates that will fit on your graph, so sometimes you have to bear in mind where you should draw your y-axis. I always tend to look at the largest number or the largest coordinate value, that is my x. So I realize that this is 6, and the smallest is going to be -2. So I don't need to go too far to the left, and I don't need to go too far to the right. Considering I'm going to be doing an enlargement, I know I'm going to need a lot more space on the right side. So scale factor is -2. I'm going to need a lot more space on my left side actually, because when I multiply this 6 here by -2, I'm going to get -12. I'm going to have a lot more space here on my left side. So what this means for me now is that this is just how I go about looking at this before I actually start drawing my x and y axis. So the first thing I'm going to do here is to just I'm going to just pretty much draw my y axis more over to, let's say here, that this side. Let's just try this line here. Hopefully I can get 12 on the left and I can get 6 on the right. Alright, that's what I'm working with, and I'm just going to be drawing my, let's see here, I'm just going to be drawing my x-axis here, pardon me, maybe down here perhaps. Okay, oops, let's just get that knitted up. Okay, alright, so here, just perhaps about here. So this should be suffice. Alright, and I'm going to be using a 1-to-1 scale. Alright, so I'm just going to be labeling these. Alright, each of these is, say here, 1, 2, All right, let's see here. I could have gotten a graph paper online, but it doesn't have a large enough scale, so I'm gonna have to create my own graph here. All right, this is 3, 4, 5, 6, a little bit close, but you get the idea. -1, -2, -3, -4. I know I'm gonna need about -12, so I'm just gonna continue. -6, -7, -8, -9, -10, -11, -12. I know I'm gonna need about -12. So there we go. All right. So I'm gonna be going up here. 1, 2, 3, 4, 5, 6, 7, 8. All right, and then down here would be -1, -2, -3, down a little more, -4. Let me just double check to make sure that I've drawn my scale correctly here. I know that the largest value on my x-axis here is going to be all right, let's see here. The largest value on my x-axis here is 6. When I multiply, I think I'm gonna need -10, so I'm not so certain, guys. Let me just take a pause and set this up for you. All right, guys, so I have drawn up my graph here for you. I've just drawn it while the video was on pause, and so I'm not gonna label the actual increments here because I'm using a really tiny graph. It's going to make the graph a bit too crowded. So the assumption is that each of these vertical lines represents 1, and each of these horizontal lines going up on my axis represents 1. All right, so we're just going to improvise here. All right, so the points that we had initially in the question was that we had coordinate values -1, 3, 2, 5. So that's -1, 3, 2, 5, and we had here final point is going to be here 6, -2. Okay, so we have 6, -2. All right, so we're going to plot those points. -1, 3. Let's come down to our graph here. -1 is to the left and 3 is up, so that's 1, 2, 3. So that's this point position right here. And we have 2, 5. So that's 2 to my right. So that's 1, 2, and 5 up. 1, 2, 3, 4, 5. That's that position right here. And we have 6, -2. So that's 6 to my right. So that's 1, 2, 3, 4, 5, 6. 1, 2, -2. So I'm pretty much looking at this position right here. All right. And so I'm going to be drawing my graph. So that's 1, 2, 3, 4, 5, 6. This position here. So I'm just going to be making a little sketch of my diagram here. That's what I'm supposed to have. Something looking like that. Okay. Now, according to the question, we have plot our points. Naturally, that's where we have to start. And after plotting our points, now it says that it undergoes a glide reflection, which is usually a reflection followed by a rotation, vice versa, a reflection followed by a translation, or vice versa, translation followed by a reflection. And so we have to translate the object first. So we have to go to a formula that we should know to be O plus T equal I. So that's object plus translation equals image. And so all our object points there, which would have been, let's say here, -1, 3. I believe we had, say here, 2, 5. And we had 6, -2. Those would have been our object points. And we're going to be adding that to the translation vector, which according to the question here states that the translation vector is -2, 3. So that's -2, 3. Okay, so that's -2, 3. All right, so that's the formula for translation. We're going to be adding each of the x ordinate values to the x value of the translation vector. So that's -1 plus -2 gives us -3. 2 plus negative 2 is 0, and 6 plus negative 2 is 4. All right. Here we have 3 plus 3 is 6, 5 plus 3 is 8, and minus 2 plus 3 is 1. And that would give us the coordinate values of the pre-image of E, F, G. So this is the pre-image, not the actual image that we want. The pre-image that is before it undergoes the reflection. So let's just plot those points, because they did say that they wanted to see the pre-image. So that's minus 3, 6. So that's, let's see here, minus 1, minus 2, minus 3, 6. 1, 2, 3, 4, 5, 6. So that's this position right here. Then we have 0, 8. So that's 0 on the x. I would be still in the origin, and I'm going to go 8. So that's 1, 2, 3, 4, 5, 6, 7, 8. Alright, and then now here I'm going to be drawing plotting, pardon me, 4, 1. So that is 1, 2, 3, 4 up 1. So that is right here on this position, same place, a part of this shape here. Alright, so I'm just going to be using a blue to overlap, and so we have here this pre-image. Alright, this pre-image that we have here. Okay, so it's just going to overlap a little bit, but that's fine. All right, so that is our pre-image that we're looking for. Now it undergoes a reflection in the line y equals negative x. Now, I would have already taught my students basically what occurs across that line. And across the line, so let's say reflection in the line y equal negative x, there's a change that's going to occur with the points. So usually our typical point is labeled xy, and so under the reflection in the line y equal negative x, you would have a interchange of the coordinate values and a change in its sign. That's usually what occurs. Now we could actually develop a reflection matrix from this by saying that it's 0. It is 0 here, negative 1, negative 1, 0. That's the reflection matrix for a reflection across the line y equal x. Now I haven't taught my students how to do matrices as yet, but for those who would have known this, then naturally you would use the 0 here that you have, that is the 0 here, minus 1, minus 1, 0, and you'd multiply it by the pre-image, which is minus 3, 6, 0, 8, and 4, 1. And after multiplying it, once you know how to do row by column matrices, you would find out that the exact change that I had predicted here is what's going to occur. So you're going to have a flip in the minus 3 and the 6, so it becomes minus 6, positive 3. A flip in this, you would have minus 8, 0 cannot be negative, and a flip in this would have minus 1, minus 4, and those would have been the coordinate values of E prime, F prime, G prime. Now I haven't taught my students how to do the row by column, but they would have already known, and hopefully you now know that once you reflect a line across, once you reflect an object across the line y equal negative x, there's an interchange in the coordinate values and a change in the sign. So if we plot this here, if we plot these points over here, we're going to find that our image undergoes a glide reflection. So negative 6, 3, so that is 1, 2, 3, 4, 5, 6, and that's up 3, 1, 2, 3. All right, then we have minus 8, 0, so that's 1, 2, 3, 4, 5, 6, 7, 8, and that's minus 8, 0, so I would have been still here on this line right here. And then now I would have here minus 1, minus 4, so that's minus 1, 1, 2, 3, 4, that's down here. All right, so if we zoom up here and just try to construct this complete image here, The one in red is the actual image that the question is asking for. The one in blue there is the pre-image after the translation. And so basically you find that the object is pretty much reflecting itself across this very special line that we have here. Okay. All right, so that's pretty much the glide reflection of this object. This is the actual line that it's passing through, guys. Okay, this is the actual line, y equal negative x. That's the actual line. So you'll find that there is an equidistance separation in terms of units between the object and its image. And this is the line y equal negative x. All right, you can literally draw this on paper and crease your paper across this diagonal line here, and you'll find that this blue object here maps exactly onto this blue object here. All right, so that is pretty much what we're looking at there, guys. So hopefully you're clear on that. Let's move on to part 2 of this question. It says that E prime F prime G prime, which is the one in red, that's the ending object, the ending image that we're looking for, undergoes a third transformation of an enlargement by scale factor k minus 2. Our first task is to write down the enlargement metric. So for those of you guys who would know about enlargement metric here, and I think I can erase this here, you guys should have this down on paper. All right, so let's see here that the enlargement metric formula is actually here k00k. That is the enlargement metric formula. So the enlargement metric layout. Now, if it is a case where, for example, in what we're doing here, that the scale factor k is negative 2, then the enlargement metric is just minus 2, 0, 0, minus 2. All right, and that would pretty much answer that particular question, writing down the enlargement metric. So if we now next now look at the following question, you'll see here that it says calculate the coordinates of the image E double prime F double prime G double prime and draw its image. So this is pretty much done like what we just did moments ago. We're going to take the actual metric and we're going to multiply it by the E prime F prime G prime coordinate values. So this is minus 2, 0, 0, minus 2, and we're going to multiply it by the image points that we had calculated earlier in red. Let's double check because I had erased the screen. So we have here 1, 2, 3, 4, 5, 6, 7. Or let's see, that's 6, negative 3. So the first point here is 6, negative 3. I think it was minus 8, 0. And I believe that this point here is minus 1, minus 4. That would have been our final coordinate value, minus 1, minus 4. Again, for those who are aware of the row by column technique for multiplying matrices, then you can go ahead and do so. But pretty much what's going to happen is that our object points, our coordinate values are going to double. It's going to double negatively. It's going to double, but all the signs are going to change. So we're going to have minus 2 times 6 is minus 12. And I had already predicted from the start of the video that I know I'm going to need a lot more space on my left side of my graph, hence why I drew my y-axis so far to the right. So minus 2 times 6 is minus 12, and minus 2 times minus 3 is positive 6. Minus 2 times minus 8. Ooh, I got minus 16. Hopefully I can get 16 out there. So that's minus 16. That's a big number. And minus 2 times 0 is 0. Alright, so minus 2 times minus 1 is positive 2, and minus 2 times minus 4 is 8. So I'm hoping I can get 16 on my left side. If not, I'm going to have to improvise, guys. But let's just go right ahead and use a different color ink here. Let's use pink, or let's use, say, orange. Alright, and we're going to plot our points. So minus 12, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And 1, 2, 3, 4, 5, 6. So I would be here. All right. minus 16, 0. So I'm actually at minus 12 here. So that's 13, 14, 15, 16. Good graph. 16, 0, I would have been right here on the line. And then we have 2, 8. So that is positive 2. That's 1, 2. And up 8. 1, 2, 3, 4, 5, 6, 7, 8. All right. And basically here, once we connect those points, let's say 2, 8. All right, let's double check. So that's 2, 8. So that's 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So that would have been right here. I think maybe something is off. Let's see here. Minus 2, positive 8. Don't think something is wrong with my coordinate values here, guys. Let me just double check on that. Alright guys, so I think I had made an error in terms of this point here. I had written down here 6, negative 3 for this point when it's actually minus 6, positive 3. So that's why my points look a little bit off, because if I connect these 3 points, it would not look similar to what I initially had. So I need to change this coordinate value here, and it's supposed to be minus 6, pardon me. It's supposed to be minus 6, positive 3. All right, and then once we multiply here, we're gonna get positive 12. All right, so that's positive 12, and we're gonna get here negative 6. Okay, we're gonna get negative 6 here. So minus 2 times 3 is negative 6. So we're gonna have to replot this particular point here. All right. So we're gonna have positive 12. Let's just erase here. So positive 12 and down 6. So let's just zoom out here. Positive 12. Hopefully I can get it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We just made it, guys. 12, 1, 2, 3, 4, 5, 6. We just made it, guys. Just made it. We just had enough space on the graph. All right, so we're all the way down here. Now, I think it looks a lot better. Or does it? Okay, it would have to be something like so. It's supposed to look sort of identical. Something like that. I think I'm a little bit off, guys. I need to double check that point again. Just give me a moment. Alright guys, so I think once again I made an error with this positive 16. This is supposed to be positive 16. I realize here that I have minus 2 times minus 8 is actually minus 16 when I should have had positive 16. So in fact, it seems as if my graph has to be redrawn, and I'm going to need more space here on my right side because I can only get 12. But let's just improvise here. Let's just get rid of this point here. Whoops. So get rid of this point here. I would have had to have 16 zeros. I would have been more on this side here. So I'm running out of space, guys, but I should have an enlarged figure. What I want you to do for me, guys, is just to plot these correct points here and let me know in the comment section if it looks a bit bigger, but at the same time very much similar in appearance or identical, so to speak. All right, but I've run out of space here, guys, so just plot these points for me and let me know in the comment section what you got. All right, but that's pretty much how you go about this question. It wasn't a challenging one. Needed to have a pretty good scale. You kind of needed to preempt what would happen to the points. I had pretty much thought that I would have got negative coordinate values here, hence why I drew my y-axis more towards the right. I should have drawn my graph more towards the left side, so I would have needed my y-axis to be more somewhere over here on this side here, like that. All right, but let me know in the comment section, guys. Thank you so much for joining this tutorial. It was a little bit rigid, but I hope you get the concept. All right, so let's see you in the next tutorial. Bye bye.